Okay, let's begin our study of square roots in 9.1. And what we are trying to do here today is we're trying to evaluate and approximate. Let's try to see if I can highlight those. No, I can't. So we're trying to evaluate or solve and approximate square roots. Some square roots just don't come out as nice numbers. Okay, here we go. When we do the definitions here on this page, on page 181, we're not going to write a ton. Actually, we're going to write a lot of examples. So let's start here. Here's what we can write. If, oops, let's use a different color here. If, and we have to write this like this. If b squared equals a, so think about some numbers that might go there. For instance, if you said the number 4, if you squared it, it becomes 16. So in that case, b would be 4, a would be 16. So if that's true, then b is a square root of a. Okay, that seems pretty easy. So let's give it a quick example here. So if we're talking about, let's go back to one I think we just said was 4 squared is 16. That's pretty much, people believe that's true. So if we talk about 4 squared being 16, that means b is this one right here. B is the 4. That's the square root. And the square is 16. Now you might, in fact, I'd like you to write this too. You might be familiar with writing it like this. If we say the square root of 16, we talk about that being 4. Now there's actually a second answer, which we'll get to in a second. So let's do a couple positive square roots. The square root of 36. Now think about what number times itself would give you 36. And that's 6. Now, some people may know already that there's a second answer here, but when we talk about a positive square root, we're talking about this thing right here coming out to a positive number. Okay, and here's a second example. Square root of 81. Square root of 81, think about what number times itself comes out to 81, and that would be 9. And we also have something called a negative square root. So let's go back to these examples up here. Sometimes square roots come out to negative numbers. Let's try 36 again. When you talk about 36, there's a second number that also times itself equals positive 36, and that's negative 6. And then there's, let's go back to the 81 here. In addition to 9, we also have negative 9, because negative 9 times negative 9 is a positive number, and it's 81. Now, in case these seem confusing, we're going to actually put all this together later. All right. Now, for the radicand, let's use something that a lot of people know, and that's square root of 100. So this thing right here, the number 100, that's called the radicand. We won't get too worried about the definition for that one. The next thing is called a perfect square. Now, perfect squares just kind of come out nicely. So let's do something like this. When we talk about the number 5, when that's squared, it comes out to 25. And when we think about maybe the number 11, and you square that one, that comes out to 11 times 11 is 121. So these two things right here, the 121 and the 25, those are called perfect squares. And finally, the radical expression. Radical expression is this. It is an expression written with a radical symbol.